begin. Okay, so good morning, good afternoon, and good evening. Thank you very much for joining us on this, our now 7th webinar on the topic of the great transition from agrarian to an urban industrialized society. We've covered a huge number of topics over the past 6 webinars. And most importantly, during the last webinar, we covered the topic of climate change, a history of an understanding of the topic, trying to understand what climate change really is. And today, based on that understanding, what we would like to do is to really understand, can it be solved? And what would it really mean to solve it? And is this even the most important issue that we should be trying to solve? Most importantly, Alexander will be giving us, talking us through all these subjects. And without further ado, Alexander, the floor is yours.
Thank you. And I will try to start my presentation. Okay, now it's here. Hi, everybody. Today I will talk about one of the most important topics from the present agenda of the world. So everybody are talking about the climate, everybody are talking about the necessity to fight the climate change and to find the solution and to scale this solution very fast and to zero emission and to make a green deal, to go to the green future and so forth. Unfortunately, I will talk in a more maybe pessimistic tones because I don't like this approach like a self-deception. And I will try to demystify a lot of wrong memes, what we have in our brain using mass media and using this internet information bombardiers, what we have. And I will talk about the whole 21st century for the next 80 years, and I will try to show you how hard is this battle for climate fixing and repairing, and why it's for the long term period of time, and why for the next decades you will constantly you will see and you will hear about the new problems with climate, and you will try to understand why we couldn't go faster, why we fail, why we are not succeed. Because for the next several decades, we will be in both trends. One trend, unfortunately, will lead us to the climate catastrophe, and not only, unfortunately, the climate catastrophe, but maybe the more general type of catastrophe. And another trend could lead us to the brilliant future, to the sustainable future, to the nice future, but it takes many decades. So this is battle for many generations, and we couldn't do it faster. And I will try to explain you why. And the important thing you have to change in your brain, that there is a huge difference in the present situation in the first wave countries, in the second wave countries, and in the third and fourth wave countries. Third and fourth wave countries, how you understood from the previous webinars, are at the beginning, at the starting point of the great transition. And the great transition, this is a mega trend, what we see for the last 250 years, and we will see for the next 100 or 150 years. And this mega transition is the fundamental fact of a progress of our history and of our future. And because these countries are on a starting point, they need to repeat all the steps what the first wave and then second wave countries were done for the last 250 years and for the last 50 years. And many of these steps, without any doubts, will lead and will bring us a lot of negative side effects. We don't need these side effects. We don't want it. They're unwilling side effects, but they're absolutely natural results of many technologies what these countries will need to use, of many processes these countries will develop, will grow, will spread, and so forth. And you need to understand that the regional difference in the next several decades will be huge between the first and wave countries. And the agenda will be different from in the first and the fourth wave countries. And if California or Denmark could be green in the next, I don't know, 30 years, and could go 100% to renewable energy sources, to green agriculture, but I don't believe in this, but nevertheless, I believe that the situation in these regions and in these countries could be dramatically better than the situation in India and sub-Saharan Africa. The main lesson or the main understanding of this battle is the understanding that to fix the climate, we need to change almost everything. So the most fundamental technologies and processes, what we use naturally for the last 100 years and 200 years, and we need to change them. We need to replace them. We need to find another technologies, and we need to scale these new technologies and do it fast. And this is unprecedented scale. That you have to understand. And if you believe that it's possible to change everything and fast, you are optimist. And you don't believe in this, people will say, okay, you're a pessimist, or maybe you are like alarmist. But that's not the point. That's only the difference in your hopes and your beliefs. What will be the reality, we don't know. But we know for sure that it takes decades to change more or less significantly the path what the humanity is going now. And I will try to explain you why Tesla is not the game changer. It's a small story, and you will understand it. When we understand it better, you will understand that we need much more discussions, much more information, and mass media should change their focus on this Tesla and batteries and how much kilometers we could drive on one charger and so forth. One of the most sad things I'm thinking about for the last several years is the understanding, the rational understanding, that maybe even after several decades of this battle, we will not succeed. We don't have enough time, and our speed is not enough, and our scale of transformation is not enough. And what's in this case? How should we think about this battle? Is it worth doing, or is it not? So this is very important question for myself, and I think for many of you. And the more important question I'm thinking about is the question, and I'm sure now that the climate change shouldn't be the main and the most important focus in the 21st century. The focus should be different. And we will talk about this in the next webinar, or in our last webinar. But this is very important question. And when you start to think about this, you could imagine the world, the existing world, without problems with the climate. We don't have climate change. We don't have these problems with the greenhouse gases, concentration growth, and so forth. And what does it mean? will the future in the 21st century will be brilliant, will look like we were building the paradise, and at the end of 21st century, 11 billion people will live in a much better world that we have now, or we still will have a lot of doubts and concerns and worries and about the future. And this is very important question for all of us. We need to think about this. And there are a lot of information now, more and more information. And I tried to collect this information when I started to learn this topic 10 years ago. And it was very little information 10 years ago. And now it's a mess of information with explanation what are the sources of emission of greenhouses, and which sector is emitted more, and which gases are more dangerous than another gases, and so forth. For example, from such diagrams, we could see that about 74% of all greenhouse gas emissions are coming from the energy production. And the rest of like another 25 or 26% are connecting with agriculture and some waste processes, and a little bit with the industrial processes, but not based on energy production. So, for example, the cement is using some energy processes and some chemical processes. So this here is the chemical processes in cement, and they in the total greenhouse emission, they cost like 3% to us. But this is only chemical part of the cement production. And another energy part of the cement production, for example, we need to burn natural gas to dry the substances the cement is doing from. And this is another part of cement production. So if you bring together this energy part and this chemical part, you will see that cement cost us not 3%. The cement cost us 7 or 8% in the total greenhouse emissions. So I collected for many years this specific data with the gigatons of emissions, and I didn't finish yet, because if you take a lot of different graphs, you will see that the data is not correlated between each other, but I will try to use this data, and I will try to using this data will show you why for example, Tesla is not the main focus, shouldn't be the main focus, and why there are a lot of other concerns about climate. And the most fundamental understanding is what sectors emit and how much, which sector emit and how much. And we know that, for example, 1/4 of all greenhouse emissions is going from the electricity and heat production. But you have to understand that electricity and heat production is the result of a power plants working, and the power plants burn coal and natural gas usually. And about 40% of all electricity in the world are producing from a natural gas and from a coal burning, and another 60% from natural gas burning. So, but this electricity, what it's producing, is split in between two sectors. One part, we could say that 50-50. It's not this, but because in the US, it's 70-30, in China, it's 30-70. The 50%, the first 50% of electricity from power plants are coming to our buildings, residential and commercial and public and so forth, so to our cities and to this infrastructure. And another 50% is going to industry. And there are a lot of industrial processes and the tools and equipment and machinery which are using the electricity. And then you could go to the industry, and the industry is emitting the greenhouse gases using another portion of direct burning of hydrocarbons, first of all. A lot of steel, 2/3 of a steel melting using the coking coal. So it's a coal, and this coal is burning directly in a blast furnace process, and this is like additional part of emissions. And for example, same we are emitting when we are producing plastic, using petroleum and using natural gas and so forth. When we are making cement, what I told you, and when we are doing nitrogen fertilizers using natural gas, part of natural gas is burning for having the heat, and another part of natural gas is like direct reaction of ammonia production. So, and the 14% of the emission is going from the transportation sector, but that's not a clear explanation, the transportation sector. And I will try to explain you much more clear what does it mean, the transportation sector. And as you see, 24% of emissions are coming from agriculture, forestry, and we could say. And the 6% of emissions of greenhouse gases are coming from buildings. This is very specific way of emissions, because many buildings in many countries, millions of buildings in many countries, are using the natural gas, which is coming into the house or into the building through the gas pipeline and burning in a furnace. And these buildings has so-called dry air or heating air technologies of heating the building. So, and because this natural gas is burning in millions of houses, buildings, so these buildings are emitting the greenhouse gases. So there are different, as I said, there are different views and the focus. And for example, there was a great publication a couple of years ago about the food sector, which according to this estimation, the food sector is responsible for 26% of greenhouse gases, and even only livestock or meat and milk production, what we could see, has a 30% of this emission. It's very close to all the emission from the transportation sector. That is why quite often you could read that kettles give us same amount of emissions, greenhouse emissions, like passenger cars, for example. And if we look at the history, we could understand that all industries and all emissions from all kinds of industries grew up for the last, at least for the last 200 years. But the most rapid growth was from electricity and heat production. This is the most important part of our life, because we need electricity and heat, as I said, for all kinds of buildings and for many processes in industry. And of course, the transportation sector grew from zero in 1900 to like 8 billion tons a year, and many other sectors grew up. And another view on these emissions is the view through the kind of gas which are emitted. And about 75% of emission is a carbon dioxide. And that is why, for example, for many years, I misunderstood the importance to look at the all greenhouse gas emissions, because all the information I've read for years was about carbon dioxide emission, because carbon dioxide emission usually goes from the burning the hydrocarbons, from the industrial processes, from the energy technologies. But as we see, 11% of carbon dioxide is producing through the deforestation and other land use processes, what are not in our focus now very often. And 16%, about 16, 17% of emission is the methane emission. Methane is 30 times more aggressive in terms of global warming potential than carbon dioxide. And nitrous oxide has another 6%, and even F-gases, I will tell you about F-gases later, has now 2%, and it was like 0% 100 years ago, believe me. And so if we look at the history, we could see that carbon dioxide grew up constantly and significantly, and methane and nitrous oxide and the F-gases didn't grow so rapidly. But the future in the 21st century will be different. I will show you. And there are a lot of these very complicated diagrams, like some K diagrams with a balance. You have all kind of resources you are burning, and you have all these sectors, and you have all these gases, and you could see that, for example, methane and nitrous oxide has the sources not only in agriculture, but in many industrial processes, but with a smaller portion than agriculture, for example. And as I said, just the most important and the most dramatic gas is carbon dioxide, and the emission grew up from a zero before the Industrial Revolution to 40 billion. Last year it was 43 billion tons of carbon dioxide emission only. And the coal and oil and later natural gas are playing the main role in this emission, because the coal and oil and gas are hydrocarbons. So the carbon is inside. This is the carbon consistent molecules. And when they are burning, the carbon is becoming free and goes and in the reaction with oxygen through the burning process. And we have CO2 like a natural result of burning of hydrocarbons. And you see this like hockey stick, not in demographic transition, but in a greenhouse gases transitions. And now we have a lot of understanding about the rapid growth of greenhouse gases. And the main focus in the mass media usually are on wind and solar technologies and this huge so-called energy transition, and on Tesla and electric vehicles and the topics of batteries. We need to create the bigger batteries and more efficient batteries, and we need to create the industrial-sized electricity storage for cities, because we need to accumulate this electricity from solar and wind. But all these discussions are about electricity, because solar and wind could produce mostly only electricity. But electricity, as I mentioned in my previous webinar about energy, electricity has only 18, like sometimes in some countries, 20% in the total energy balance. As I said, a lot of energy we have burning oil products. This is a transportation sector. About a third of energy we have burning the oil, and another third part of portion of energy we have burning natural gas and coals in industrial processes, direct burning, and we have direct heat and direct different kind of. And this is like the picture to understand better what are the sources of energy for our civilization. And if we go to the parts of these emissions, we have to understand that in the next decades, we will see the huge growth in terms of scaling the technologies and processes, which are the fundamental and the basic processes for modern civilization, post-agrarian civilization. So, and because we understand that a lot of countries from the second and especially third and fourth waves, are in the process of the great transition, in the different stages of the process, we need to understand that we will continue to see the growth of using on many so-called dirty technologies or greenhouse gases emitting technologies, and it's impossible to change fast. For example, China announced that China now has the biggest electricity installed capacity in the world, around 2 terawatts. And the US has a little bit more than 1 terawatt, and the Europe has 1 terawatt. So the China announced that because 1 terawatt is not, or 2 terawatt is not enough for China, they are going to increase the installed capacity until 3.3 terawatt in 2050. And the huge bulk of this growth will be from using the solar and wind technologies. So the world is applause and say, wow, China is creating the biggest renewable technologies like shifting in the world. But these technologies will not replace the coal power plants. These technologies will plus or will add to existing energy system based on 60% of this electricity today. China is receiving burning coal. So, and even in this, after this huge progress, building 1 terawatt of renewable electricity capacities, China still in 2050 expect to have 40% of a total energy from burning coal. So same in India. India now has like 6 times less electricity installed capacity than China with the same population size. For sure, India wants to increase its power plants capacity, and according to the government plans, by 2047, India will get 1.7 terawatt of installed capacity. And the main question for Indian government and for many experts is it possible to build another 1.4 terawatts of electricity power plants using only solar and wind technology? And this is the huge discussion in this, because nobody did it before. No one countries made electrification and industrialization and urbanization based on something excepting coal technology, excepting coal. Because for industrialization, you need to produce a lot of cement and steel. And as I said, the steel technologies now are for 80% of steel technologies are based on coke. So we could expect that for huge urbanization, and India will need to urbanize 1 billion people for the next decades. So to build 100 New Yorks, yes, something like this. And for this, India needs about, I don't know, 1 gigaton of steel per year, and maybe at least like half a billion ton a year of steel. And it's very hard to produce steel now without coke. And so we could expect that the coal will play the important role in India for these decades. And according to many experts, in 2050, India will get 50% from its total balance from coal. 50% of the energy balance in India will be based on coal and coal burning technologies. And there is this slogan from United Nations, energy for all. And this slogan means, first of all, helping the first wave countries or sub-Saharan countries from sub-Saharan Africa and from South Asia, because these countries are so poor and so they have the energy poverty. So they live in a situation when, for example, the whole sub-Saharan Africa with 1 billion 1.1 billion of population, has 50 gigawatts of electricity installed capacity, 50. And the US, with 300 million of population, has more than 1 terawatt. So this is 20 times difference in electricity consumption. And of course, knowing of this and knowing that electricity means fundamental needs of a modern post-agrarian world, we could predict that for sub-Saharan Africa, with the huge rapid of urbanization and industrialization, it will be necessary to have in 2060 at least 2 terawatts of electricity installed capacity, maybe 3 terawatts. So this will be the new electricity construction boom in sub-Saharan Africa. And the main question, of course, is from the first wave countries and from the scientists and politicians is, could we permit to sub-Saharan Africa countries to build their coal-fired power plants? And the question is, and this is the real civilizational conflict between these different worlds. And we will see more and more inspired speakers from these fourth wave countries. And these speakers will argue that, guys, from the first wave, you need to remember that you emitted for the last 200 years. And you're responsible for about 70% of cumulative emission of greenhouse gases, because you emitted during 200 years. And now you have the amazing level of energy consumption and lifestyle, and based on this hydrocarbon energy system. And so we think that you could not prevent us from building coal-fired power plants, or at least natural gas-fired power plants, because it's impossible to make urbanization in a pace of 2 or 3 billion people in the next decades, and industrialization without coal and without natural gas, based on solar and wind technologies. So Africa is responsible now for less than 1% of cumulative emission of greenhouse gases. And of course, they're asking, guys, we don't need your permission. We need your help to help us to go through this great transition, because you have an experience, you have money, you have capital, and you could help us. We are together. We are in the same boat with the name, the Earth, the planet Earth. You need to help us to go through this transition and not to damage the biosphere, and locally and globally for all of us, because you could not distance from us at this planet. Unfortunately, the climate change is the global problem, and but we need space for progress. So you need to cut to zero your emission, and you will give us a little bit space for growth. So this is one of the main conflicts, and I'm sure we'll see more and more discussions around this conflict. And if we are thinking about transportation sector, and as I said, we are thinking that, okay, Tesla is a solution, and we will rapidly change everything in the world. But we need to understand that now we have 1.4 billion petroleum cars, or internal combustion engines. So we have it in passenger cars, in trucks, in tractors, and shipping, and everywhere in aviation, even aviation. And we have to understand then every year the car produce about 70, 80 million petroleum cars. So in 20 years, we will have about 3 billion cars in the world. And according to all the experts, only in 2040, we will see maximum 400 million, or for many experts say 200 million electric cars in the roads. So we will get the park of 2 billion passengers cars, and only 400 million, so it's a quarter. And this trend will continue because, as you see, the penetration rate or the ratio of the number of cars per 1,000 people is so different in the first wave countries and the second and third and fourth. You see, the United States has 800 cars per 1,000, and the China has 200. So if you do the math, you could understand that if China has the same penetration rate as the United States, the China will have more than 1 billion passengers cars, only China will have. And if you look at the India now, 28 cars per 1,000 people. And if India will have the same penetration rate like the United States, India alone will get about 2 billion passengers cars in the country. So this is, and when we see the like official, more or less official forecast based on the China government, they expect that now they have 250 million passengers cars in the country, petroleum cars for sure. And in 2050, they expect to get 500 million passengers cars. So double and the plus 250 million. And the discussion is, okay, could we replace and could we produce 250 million electric cars? But as I said, you need to remember that if now China will replace all these new cars by electric cars, these cars will be 60% of coal-based cars because they will charge from the regular electricity system, which is 60% based on the coal. So this is not a huge paradigm shift. This is like very complicated picture. And you need to remember, this is another topic. All cars have the cooling system, air conditioning. And these cars or mobile air conditioning are the main source of F-gases. And as I said, F-gases now has only 2% of share in the global greenhouse gases emission. But this share grew from 1% for the last 15 years. And for the next decades, because we understand that the number of cars will double or triple, or maybe quadruple in this century, if something will not change significantly. But based on this existing trends, we could predict this future. And based on this, we could expect that the emission of F-gases from these mobile electric air conditioners will double or triple or quadruple in the next decades. So the next topic is the methane emission. So as you see, the main source of the methane emission is the fossil fuel production. And the second is the livestock farming. And if we look at this, emission from energy sector or from fossil fuel production, we will see that this is the so-called fugitive gas emission. And this fugitive emission is equal to 2.5 gigatons a year. And this is the result of oil and natural gas exploration, not extraction, but exploration only. So you need to drill thousands of these holes when you try to find the new gas field and or oil field. And of course, through the process of extraction, we have the fugitive emission, and from the hydraulic fracturing technologies, and from the shale gas separation, and all these new technologies we are listening for every day about the future of oil and gas industries. They are producing fugitive emission, and this is one of the most rapidly growing part of the emission. And the next part of the methane emission, as I said, is the livestock. number of kettles, and it's equal for about 3 gigaton a year now. And the number of cattle, what we know from my webinar about the food and the food past and future. And as we know, we need to double or triple the volume of milk and meat in this century. So that means that the number of cattle or number of heads will double or triple, and the cattle is the main source of this methane through the enteric fermentation process, and it's unstoppable. You don't need Tesla to stop this kind of emission, but you could not replace the cars to the electric cars. And our hopes that artificial meat technologies could replace this cattle are naive, because we need to produce between 300 and 600 millions of tons per year. And the same rice production is the next source of methane emission. And even this horrible kind of waste production, because we, like a civilization, produce a growing volume of waste, and the landfills plus crop burning. It's a natural process in agriculture, crop burning. These two processes give us about 3 gigaton a year of emissions, the total greenhouse emissions. And then we will go to nitrous oxide. This is 300 times more aggressive greenhouse gases than CO2. And you see the main source of nitrous oxide is from agriculture. And what is in agriculture? This is nitrogen fertilizers using. We have this growing nitrous oxide emission from the process of producing nitrogen fertilizers and using them in the soil, because these nitrogen fertilizers are not using for 100% by soil and by bacteria, but only for 20 or 30%. So, and all other fertilizers are coming to the rivers and seas and oceans and so forth. And as we understand, because we need to double or triple the global food production in this century, we need to double or triple the nitrogen fertilizer and phosphorus fertilizer use. That's unstoppable, and that's unchangeable. And I started to talk about F gases, and there are many articles I didn't expect, but then I realized that that's true. In these articles, these F gases are called, I call them like the new global threat, because they are 1,000 or even 20,000 times more warming potent than CO2. So one molecule of F gas catch 20,000 molecules of heating photons, what reflected from the Earth, as I explained to you in my previous webinar about climate. So now emission is like between 1 to 2 gigaton, and it's like the real emission is about 10 million tons a year, 10 million. But this is like about several dozens of F gases, so-called CH6, SF6, and so forth, and with a different pattern, with a different warming potent. But this volume will grow, as I said, because of the number of cars will grow rapidly in the world, especially in the second, third, and fourth wave countries. And urbanization in the third and fourth waves, we need to urbanize 4 billion more people than we have now. We have now 4 billion urban dwellers, but we will see same amount in the next several decades. And all of these people are from tropical zone, plus 30 degrees in the north and 30 degrees in the south, around the equator. And so all these people will need the refrigerators and air conditioners for sure. That is why the number of these cooling appliances will double or triple in the next decades. And all of these appliances are using the F gases like refrigerants. And of course, because these countries are building the industrialized food chain system, and this food chain system needs a lot of refrigerators, because this is one of the main important part of cutting the losses in this agricultural system or in this food chain. And because of we understand that the park of passenger cars, and not only passenger cars, all kind of cars will double, triple, or quadruple in this century. Same. And even tennis balls, as I said, you could find that we are using these F gases, this kind of F gases specifically with a potent 20,000 times more than CO2 in the tennis balls. And because we couldn't stop playing tennis because of we worry about the global warming and the climate change, this is one of the main problem in our brain, because we are talking about very often in a very optimistic tones about the future and about the chance to win, but we couldn't stop playing tennis, despite we know that how bad it is. Things for us. And there are no scalable, as like one of my best expert, Václav Smil, he explained this in detail. There are no scalable technologies for steel production based on something new like a hydrogen. All discussions about hydrogen, we will see more and more discussions in the next decades, but we need to understand that the hydrogen is totally new technology. And for decades, we will see the bulk of experimenting with these technologies. For example, like a couple of days ago, the biggest shipping cargo company, Maersk, announced that they will not order any new ship in the next 10 years because they need to wait the progress in hydrogen engine for ships, because if this hydrogen engine will look like reliable and good, they will order the new ships with a hydrogen engine, because they understand if they order now the traditional diesel-based or diesel-fired ships, they will pay at least like greenhouse gases taxes, and will be just penalty for many different in many directions. So this is one of the most dramatic period in our life and the life for investors, for industries, because many industries and many investors don't understand now where to invest, because they are worried about the next decades, that everything should be changed, but it's unprecedented scale, of course. And there are no technologies for heating the buildings. And again, some buildings are using heat water, some buildings are using gas and furnaces. And so if we are thinking about the solar and the wind, and they produce only electricity, it doesn't matter clean electricity or not clean. But if you have only electricity, you could imagine that we need to replace in millions of buildings in the world the gas heating system to electricity heating system. And it couldn't be done fast. And we didn't start yet, because we don't have the decision that, okay, from now for the next generation, every house and every building have to have this electric heating system only. And we don't have the solutions for trucks, aviations, and car. And despite we are reading the publications of the techno optimists that, okay, we are now have one new kind of furnace for melting steel, burning hydrogen, not a coal. And we say, oh, this is now we will see all the blast furnaces will be replaced to hydrogen. No, according to the industrial report, we have a chance to have the scalable and reliable technology of melting steel using hydrogen not earlier than 2070, so 50 years from now, because it's not obvious. There are a lot of problems, technological problems in these technologies. But if we are talking not about technologies, but about this list of emissions, I will give you some comments about this list. For example, as I said, the passenger cars now emit about 3.5 gigatons. And if we replace all these passenger cars to Tesla or to electric vehicles, this is a solution for only 7% of all greenhouse gases. Only 7%. And as I said, for trucks, which are emitting now about 2 gigatons a year, there are no scalable solutions. And we will see it, maybe it takes another 10 years. And after this, we will have the scalable solution. And in 2030s, they will replace. But you need to remember, the climate was broken 100 years ago. The concentration of greenhouse gases, especially CO2, started to rise in the beginning of 20th century because of the result of emission for 150 years from the first wave countries, because they burned coal. The coal was the coal was foundational resource for industrialization and for the great transition for the first wave countries during 150 years. And then, as I said, we don't have the solutions for steel and cement, despite, like, for example, one of the best initiatives is Energy Breakthrough Initiatives initiated by Bill Gates. And I respect very much and I like very much everything what they are doing, but they are, I could say, on a sales side. They are investors. They are interested or they are motivated to show us this like a very promising success when they're investing in some technologies which could replace the cement without burning natural gas. They could announce, okay, now we have a solution. But that's not a solution. This is only innovation. The distance between innovation and industrial experimentation and industrial prototype and scaling of this prototype takes like at least 20 years, maybe 40 years. And so we need to understand that this is a long-term game. And as I said, the fugitive emissions, this is waste, this is garbage. But fugitive emission is about 3 gigatons a year, very close to passengers. All passengers' cars are emitting. And the livestock and the manure has the same amount. And agriculture, if we take agriculture like livestock plus soil plus rice cultivation, it's 6 gigaton. And no solutions for these emissions, no solutions. Again, the Energy Breakthrough Initiative started to invest in different projects which are trying to find the solution and to substitute the nitrogen fertilizers. But how many years it will take to find these technologies, and how many years it will take to scale these technologies to all countries, to all fields, to all crops and so forth. And of course, the landfill plus wastewater plus crop burning, these waste technologies, they give us 3 gigatons, same amount what passengers cars. And we need to understand that this list does not have the main part, like, oh, 90% of emission are coming from, I don't know, from coal power plants, and it will be easier, but it's not. We have 5%, 5%, 3%, 5%, 5%, and we don't discuss this. I never heard the discussion about fugitive emissions or about crop burning or about something like this. And only now we understand better and better that many parts in this table, many parts in this table will grow for sure for the next decades. And we could not expect that we will cut or we will zero their emission in 2050. The first wave countries could do it if they do it hard and constantly and being focusing on this. Even they couldn't do it. Several countries like, say, Denmark or maybe Germany, and they could do it, but not all of countries from the first wave. But of course, the second, third, and fourth wave countries, they couldn't do it in this decade. So we need to understand that changes, that we need to curb the global emissions, so to stop growing. Then we need to decline and to go to zero. This is very different goals, and we are even not close to the peak of global emission. But the first wave countries could reach faster this peak and then go down, and the third and fourth will continue to grow, like we saw in the demographic trends, in energy consumption, and in food consumption, and all of this. So the first wave countries could go to the new future, but the other countries will continue to grow. But then we need to zero the emission, the global emission, and then we need to absorb from the atmosphere about 2 trillion tons of anthropogenic greenhouse gases, which are accumulating in the atmosphere. 2 trillion tons. And now the absorption of this, and we don't have a solution for this. We don't have technologies for this. And based on our technological westernized approach, we will continue to look at the new technologies, how to suck these greenhouse gases. But that is why, as I said, all these technologies may not be a solution, because we couldn't zero fast, and we couldn't zero at all. So for many, many decades, we will see the growth. And that is why, for me, this idea, what I said in a previous webinar about climate, that the forest could be crucial in our strategic fighting with climate change. Because if this concept is right, it doesn't matter. Will we replace all the petroleum cars to electric cars? Will we replace the coal-fired plants to solar and wind? It doesn't matter. The climate still will continue to be worse and worse and worse. But if this concept is right, so we have totally different strategy and solution. So that is why I think we need to spend a lot of efforts to test this concept about forests, not about planting forests, but about afforestation, giving the forest the chance to increase the area. And it's very complicated because, you know, the forests struggle with meat and meat struggle with forests. And the next thing you need to understand that the first wave countries, from moral approach and from technological approach and the level of the standards of life they reached, they could hurry up and they could zero the emissions first, but they could not blame, they could not stop the development of the third and fourth countries. The third and fourth countries needs the global support in this great transition, not bans. They need to build even coal-fired plants, and they need to build the blast furnaces based on coke, not the potential hydrogen and something like this. And one of the main points what I started with is the point that the climate is the symptom of a disease. It's not a disease, it's not the root of diseases. The roots of this disease, what we get in the 21st century, based on a progress, what we see from the first and second wave countries. But being multiplied to 10 billion people, this progress will bring us the potential catastrophe. And so that is why I think we need to change the focus from climate change to more broad and more higher questions. And we don't discuss these questions right now. So that is one of the goals of our initiative, to try to change this, to shift this focus of the global agenda and stop talking about climate change and the technologies which could help us, because this is not a solution. This is not a solution for the decades from now. And we will see more and more problems. And we know for sure that we will get these problems because of the progress of another half of our existing civilization and another additional humans what we will get in 21st century. So that's my main explanations for you, and that's my main concerns about chance to fix the climate change fast, rapid, and broad. Thank you.
Thank you, Alexander. Marek, can I ask a few questions from Alexander?
Sure, go ahead.
So, Alexander, as a person with a hockey stick in the mind, from the startup industry, venture capital industry, we think like if you have the right people, right technology, R&D, enough investment, you need few years, maybe more, maybe 10, but in the end of the day, you will have some technology with a hockey stick, and then you will achieve very big results. If we are talking about results, the emissions, what we have, gas emissions, they can, in somehow, we see these technologies recently, a few years ago, we see the investment, very big investment from the some biggest petroleum companies in the world. They start to invest their money to the technologies what just they grab the gas emissions from the air, and they believe they can change the environment, they can help to environment. So why this kind of thinking can be the solution or cannot be solution? Can you explain this a little bit? I realized from technology perspective, we couldn't change the steel, and all other main emissions. But what's happened with the technologies? What just can suck the emissions from the air and start to collect them?
Yeah, again, based on the brilliant explanation of Václav Smil, which explained, he has several publications about this, and his brief characteristic of these technologies is one of the stupidest idea what we now get, because this technology is not the solution at all. These technologies will bring us a lot of risks. This technology is one-time technology, so you need to catch the gas and pipe it, push it under the surface or in the ocean or somewhere else, and then to save it. So you need to protect that any hole could happen and this gas will go to the atmosphere again and so forth. But he calculated that the scale of this industry will be equal the whole oil industry now, with all these pipelines, refrigerators, this pumping technologies, this and everything. And he said, could you imagine that we need to build the planet, the infrastructure for only one non-reasonable action to catch and put it? This is stupid. And as I said, we could catch only in electric power plants, or not in a power plants, or we could catch only in a centralized technologies, like, for example, blast furnace, cement companies, and so forth. But that's not the main source. There are dozens of another source, and they will grow. Unfortunately, we know it for sure. And so this is not a solution, of course.
Thank you, Alexander.
And the problem is that, that the world is driven by business interests, by interests of investments, and by geopolitical interests and so forth. And that is why the problem of climate change is that this battle is above all existing authorities or the centers of power or decision-making centers. This is the global problem. So every country or any company or any like CEO of the company, they are thinking about their interests, about the responsibility for their electorates and for their shareholders and something like this. So we could not, but I'm sure we could not win the battle without the headquarters. Now we don't have this headquarters. All these people, they are officers and soldiers in the battle. That is why Elon Musk could say, okay, the Tesla could be, or electric vehicles could solve the world. And because he's selling himself, his company, the capitalization of the company and everything, but he does not think like the person in the headquarters. He does not think about fugitive emission, about cattle, about just all these things. He is not responsible for this. That is the problem. We need, for sure, we need to create this place. I don't know, it will be NGO, it will be United Nations, or the new authority what should be created, not because of climate change, as I said, but because of the unprecedented transition we will see for the next 100 years. Because we understand that these 100 years will be the most dramatic. We need to change everything. And the question is, are you believe that we could change everything in the 21st century, or we couldn't? And so if you understand that we couldn't believe, that we couldn't change, what does it mean? That you believe in catastrophe? You are pessimist, you are alarmist, and this is the main focus of the discussion we need to start.
Thank you, Alexander. As Ainar often does, it's there's a feeling to want to give some kind of emotional response to what we've just heard. I think back to the very first webinar where you talked about beginning this journey into understanding all these issues from the perspective of an optimist who was shocked by the pessimism of so many experts. And one can't help feeling that throughout particularly this webinar, you're still very determined to try and hold on to some kind of optimism, see some possibility for a solution, while all the data and the experts are pulling you into the pessimistic state. And you're also adding something which is, let's say, a third voice within the whole discussion of climate change and environmental challenges. Often the term alarmist is attached to those who are trying to say, look, all the terrible things climate change can do, and not to those that are saying, look how unlikely it is we can solve climate change. Traditionally, the alarmists are ones that are saying, we need to do something radical to try and save everything, but we can do something radical. You get the videos that show all the terrible things that could happen if we don't do something. And then they say, look at what Netherlands is doing, look at what Denmark is doing, take those technologies, put lots of money into them, and then we can solve it. And yet here at the end of this video, we don't have this, everything is terrible, but here is the magical solution that will solve everything. So start writing letters to your politicians to try and get them to support that particular technology or solution. So I guess I can't ask any questions here. If there's any doubts in my mind, and even during the video, I'm trying to check a few statistics as well during this webinar to trying to really, but when you try and understand is how, we'll use the word terrifying, this scenario is, your mind immediately wants to say, well, it can't be really that bad. And you start checking statistics, and there's nothing there that can sort of really add any hope to that. So I guess my sort of question, as it were, if we could really call it a question, is you say that technologies aren't the solutions. You see a political solution whereby you have some form of leadership at a global level that takes everyone's interests into account, both those that are trying to achieve better lives in the third and fourth waves and those that are in the first waves. When we look at what are some of the solutions that such a political entity, such a political organization should be looking at? If it's not technology, then what are the questions that they should be asking themselves?
There are two comments. The first comment we need to remember, and we need to have in mind, that the people are very different. Some people are optimistic, some people are fighters, some people are pessimistic, some people are like emotionally vulnerable. So that is why it's very important to understand who is speaking. I'm quite optimistic person, like by my nature, with a lot of knowledge in my mind, what makes me a little bit more pessimistic that I want to be. But I am a fighter. So I have a background of CEO, I'm a fighter, but I prefer to know the bad truth, not the optimistic self-deception, very promising hopes. Yeah, that's it. That is why I prefer to see that all these trends, what I see, shows me the worst future, not the better. That is why I prefer to say it clearly, and if I have this understanding, I understand that everything, all our achievements in every step what we achieve are not the achievements we could celebrate, but we understand that we are battling against the worst scenario, not for the best future, but against the worst scenario. So this is, for me, this is the open-minded approach. You need to understand, you need to have this long-term vision, and based on this long-term vision, you need to talk about what needs to be done. What could we do? Is it enough? Or if it's not enough, what should we do additionally? So, but you need to have enough time for this. You need to have enough power, because even if you are thinking sitting on a beach, so you are Socrates or something like this, or Diogenes, so you are thinking for yourself. Yeah, no, I love the world. I love humans. I want to help us at least to survive, and the better, to have the better future, not the worst. Yeah, and that is why I'm thinking from this approach. But the second level is, as I said, we need, of course, to have the team, the authority, who are working on a long-term vision of the world development. We became the tied in together civilization. We came from the empty world, like it was for hundreds of centuries, yeah, before an agrarian era and hunter-gatherer. So there were millions of people on the planet. So there were a lot of spaces, a lot of resources, but now we are in a very crowded world with a very tied together nations, with everything what is like dependent from each other. So we need to change the approach to the governance of this world. We should change this previous thousands of years of approach to struggling with each other, because we have the contradictions. We are different nations, we are different countries, we have the different geopolitical ambitions and so forth. We need to understand that our spaceship is very close, it's very small. This is the only spaceship we have. We couldn't immigrate to Mars like sometimes people are thinking what's the idea of Mars. And if these people, I don't know, 100 people or 1,000 people who will immigrate to Mars, they will not survive if we don't have the civilization here. That's another mistake we are making. And I believe that we need to create this headquarter of this war, because this battle is for the long-term period of time. But again, you need to understand that I'm with a CEO background, and like a CEO, and I know exactly that before you start to implement anything, you need to see as clear as possible the future. So the goal. So if you want to move somebody, to manage somebody from the point A to the point B, you need to create first this vision of this point B, what this point looks like, why I want to be there, not here, what I don't like in this point A now, what could be. And when you create this future, this vision, you will understand much better. That is why when I'm thinking about the next century, I understand that the climate change is not the worst enemy for our civilization right now. There are much more important priorities, and we are not talking about this. So that is why I continue to dig deeper and deeper and deeper, and trying to find the better explanations, the better answers, the better solutions. Because what we have now, it's like very scary. So it's all make me sad, not optimistic.
Thank you, Alexander, for the webinar.
Thank you, my friends. And thank you.
Thank you very much.
To all, our listeners. I hope it helped them.
So see you soon in our latest webinar, very soon.
Yes.